Hello everyone, I'd like to welcome you all to this session on the WMO Global Annual to Decadal Climate Update. We'll hear about the latest update that was published at midnight actually, so it's very fresh. This is one of the most high-profile climate services that the Met Office produces, and we'll also have an introduction from Met Office experts who will provide an overview of the important work that they've been involved with the WMO over the years. So we will have a brief bit of housekeeping first. This is a hybrid meeting. We have people in person and people joining online. So if everybody in the room could keep mobile devices on silent, as it says here, it's like a cinema, but we don't have any popcorn, unfortunately. Recordings will be shared after the week. Please enter any questions in the Q&A box online. These will be relayed to us at the appropriate Q&A session. This is our brief agenda. So we will first have Holly talking over an overview of the WMO and its recent reform, and then we'll hear from Ian, followed by a panel Q&A session, and then Melissa will join us for the actual update later on. So these are our speakers that I just described, and first we will hear from Holly. As it says here, Holly is Deputy WMO Manager and Senior Strategic Relationship Manager at the Met Office. Holly has worked in the international stakeholders team in various roles, including as a project manager. So we are looking forward to hear what Holly has to say. I think this is the first of your slides. So hand over to Holly.
Hi, thanks Alex. So yeah, I'm Holly, and I sit in the international stakeholders team within the Markets Directorate. Nairi, who is WMO manager, was really hoping to join us today. Unfortunately, she's not very well. So as her deputy, I'm delighted to be here to talk you through the wonderful world of WMO, how the Met Office is involved, and our role in supporting UK government. Nairi and I make up a small team of two for WMO, but really our team is much wider as we coordinate expertise into WMO, not just from the Met Office, but other UK agencies such as the UK Centre for Ecology and Hydrology, the British Antarctic Survey, and many others, and also universities as well. So what is WMO? WMO is a specialised agency of the United Nations dedicated to facilitating international cooperation and coordination around all things related to weather, water and climate. You can see the vision there, which is very much kind of around building resilience, especially for vulnerable parts of society. And I've just highlighted part of the mission here, which shows one of the primary benefits of us being involved with WMO. Without it, there would not be a facility to gather and exchange the vital kind of observations and data related to weather, water, climate and the environment. WMO also supports national meteorological and hydrological services in meeting international commitments, particularly around areas such as disaster risk reduction, climate change mitigation and adaptation, and sustainable development. So how is WMO working towards this? So there's a strategic plan up to 2030, which importantly was developed and agreed by the 193 members of WMO. Covering the services that society needs, systems, research and support, and the key activities and organisational elements that are required. The focus areas for 2024 to 27 are currently being reviewed And this is something that our Chief Executive, Professor Penny Endersby, and others are contributing to through their roles within WMO, which I'll explain a bit about now. So as I mentioned, there are 193 countries and member states that make up Congress, which is the main voting body of WMO. It's usually the director of a national meteorological or hydrological service that is the representative for their government. And Professor Penny Endersby is the UK PR. And she's the PR into 4 regions of WMO. So WMO splits the world into 6 regions. And because of British overseas territories, we are actually a member of 4 of those 6 regions. So although we're not really involved we don't get heavily involved in some of those regions, but it does give us a really good oversight of what is going on globally and the challenges that people are facing. And it can also give us a good understanding of what some of our partners are up to in areas such as capacity development. Penny is also a member of an elected member of Executive Council, which is the governing body responsible for implementing the decisions of Congress. And one of the major achievements that through this governing body process was 2 resolutions that were agreed in 2021. The first being for the WMO Unified Data Policy, which allows for the free and unrestricted exchange of observations data. This was a big priority for the Met Office and also the Foreign, Commonwealth and Development Office. So the UK was really involved throughout the process leading up to this final agreement. And this resolution is a really good example of where it's key that we are representing the nation and not just the Met Service. All members were required to go through a national consultation process leading up to this agreement, because the data that it refers to is not just Met Service data. It refers to government and research institutes and academia as well. And one of the other big wins for last year was the approval of GBON, the Global Basic Observing Network, which is a new set of global standards that will identify and address major observational data gaps. And this will enhance the global real-time weather observing system. Now, in the Met Office, we're internally looking at how we are going to meet those new standards. And in some areas, it's kind of increasing observations from once a day to twice a day. And that is something that some NMSs will find a challenge. So linked to this is a new initiative called SOF, the Systematic Observation Financing Facility, I think I've got that right, which is being designed to support countries in meeting these requirements. And the other reason why those 2 agreements were quite a big deal was because they came at the end of a period of reform for WMO. So governments around the world called for a revision of the UN development system, and the UK government was particularly interested in this reform process. In 2018, WMO members agreed that the reform process was necessary, and so it began the process of transforming the organisational structure that had been in place for around about 70 years. And now WMO is leading the reform effort in the UN. So this infographic shows how the strategic plan is linked into the new structure. So we've got kind of 2 new technical commissions, where before there were 8. And across this structure, the UK has got a number of experts involved, and some in some very influential positions, such as Ian being the president of the Services Commission, who we'll hear from later. And also we have Jeremy Tandy, who sits on the management group of the Infrastructure Commission. As well as the positions that I spoke about earlier that Penny holds, she also sits on the Policy Advisory Committee. and Stephen Belcher and Julia Slingo sit on the scientific advisory panel. And beneath this top kind of structure, beneath the technical commissions and the research board, there are a number of standing committees and research programs and expert teams that all in all, I think we have around 70 experts involved in various capacities. This is the organogram for the Secretariat, which is based in HQ in Geneva. And as part of the reform process, we are working closely with FCDO to ensure that the Secretariat, led by Pateri Tallis as Secretary General, is working efficiently and financially and programme-wise, and that the UK is getting good value for money from its investment through delivered objectives. And like I said before, this was kind of a big priority for UK government. And as just a quick aside to this, I'm just returning from a secondment from the National Stakeholders team in the Met Office. And my work there also really highlighted how much of what we're doing with WMO and our positions within it are contributing to a lot of UK government priorities at the moment. And just to finish off, I wanted to just highlight how we are contributing climate expertise into WMO through the technical commissions and the research board. In the Services Commission, we have a number of experts on teams in the standing committees, and we got a few members on the Standing Committee for Climate Services, including some leads of expert teams. And this is something that Ian will tell you a little bit more about in a minute. So thank you very much. Thank you very much for having me. If there is any more information you'd like on anything I've mentioned today, or you want to find out anything more about WMO in general, please do get in touch with Nairi or me. We'd be very happy to talk to you. Thank you very much.
Thank you, Holly. That was a very nice overview of the World Meteorological Organization. As Holly said, we will now hear from Ian. Ian has a lot of experience in the UK Met Office and was, as we heard, was elected the first president of the WMO Services Commission in 2019. And so I think we're all looking forward to hear Ian's presentation on his experiences.
So thank you, Alex. Great job, Holly. Great presentation at the last minute as well. So yeah, I'm Ian Lisk. I'm the president of the Services Commission at the World Meteorological Organization. Holly's given you a really nice overview of how the new WMO kind of works. The thing I just want to add really is the change that we effected in 2019 was the biggest change that the WMO had ever seen in its 70-year history. We literally took everything that we've been doing for the last 70 years, threw it up in the air, and then my job has been basically as part of a team of research and infrastructure has to be put in place the new structures that actually deliver on everything that the 193 members want us to do. That's been particularly challenging because I don't know if you've noticed that for the last 2 years, obviously, we haven't had very many face-to-face meetings. That's been made things really, really difficult, actually, putting together a completely new structure over the last couple of years on the services side. But it is what it is. You can see on the title there that we call ourselves the Services Commission. This is going to be acronym soup. You'd have seen some examples of that from Holly's sort of overview just now. So the shorthand for the Services Commission is CIRCOM, but you can see that the remit is for weather, it is for climate, and I'll say some more details on that as we go through this presentation, water and related environmental services. So it's ridiculously broad in scope, to be absolutely honest. So let's go on to the next slide. Priorities for the Services Commission. Here we go with the acronyms. All right, so I'm just going to go through a few. My main job as the Services Commission President is to ensure that we are properly coordinated in terms of what we do with the Services Commission. Services Commission is an intergovernmental body. That's why I'm elected by the members. I'm not selected from a list. I'm actually had to go through all that stress of votes and all the rest of it. We're an intergovernmental body, as is the Infrastructure Commission. So we're two intergovernmental bodies. So I have to coordinate with the Infrastructure Commission, the Research Board, which is the sort of operational arm of how WMO does research these days, looking at the priorities of the Infrastructure Commission and the Services Commission. But that's a non-intergovernmental body. Researchers like the freedom of not being constrained by lots and lots of intergovernmental process. The regional associations, there are 6 regional associations around the world. We live here in Regional Association 6, which is Europe. But again, it drives all the priorities of members, those members through the regional associations. Something called the Hydrological Coordination Panel. That's all things water. The hydrologists, again, have been really, really keen to maintain their own identity through the outcome of reform. Reform's trying to make things much more integrated, but the hydrologists really, really keen to maintain a forum for their own discussions as well as integrating into the big picture for disaster risk reduction. The Joint Collaboration Board is all the Marine gang, similar sort of thing. The Marine lot like some degree of identity, and they're trying to ensure that actually everything we do, for example, with the International Oceanographic Commission, is all nicely lined up and joined up too. For this week, really, really important, the CCP is the Climate Coordination Panel. And that, again, is to make sure that with various other external agencies, we are seeking to be as joined up and integrated as we can, because one of the risks with reform, you take things to pieces and you lose some of those important links. And I sit on the Capacity Coordination Panel and do a lot of work with them, more on that in a bit. Capacity Development Panel, a lot of what WMO does is trying to raise up the standards of everybody around the world. So we, setting of minimum standards, minimum capabilities around the world. And then the Technical Coordination Committee, which again is making sure the two commissions are doing things in a nicely joined up way. What you see there basically describes my role as the President of the Services Commission and our priorities actually going forward. I'm just going to pick out a few examples in the interest of time. The second bullet is, you remember, maybe or maybe you don't, not even aware, on the 23rd of March this year, World Meteorological Day, the UN Secretary General made a surprise announcement about early warning systems. And he's basically set the WMO a challenge on behalf of the UN that in 5 years, every person on the planet will have access to and be covered by an early warning system. OK, so that's all 193 members are all going to play in that. And it's my commission, the Services Commission, that's been charged with delivering on that challenge. Now, I say a surprise announcement, a pleasant surprise. Yeah, very, very nice. Yeah, that gives us something to really aim at over the next 5 years. But it's going to take a lot of work to actually deliver on that. And you can see there's a bunch of other acronyms. Global Multi-Hazard Alerting System, WMO Coordination Mechanism, which is how we work with other UN bodies in Geneva, provide advice for humanitarian response. And obviously one of our partners in the United Nations Disaster Risk Reduction programme, again working closely with those. The third bullet down is the Global Framework for Climate Services. This is an initiative which was kicked off about a decade ago as a big flagship enterprise to bring everything together that WMO does with partners on climate services and seasonal forecasting. It was started with a big fanfare about a decade ago. It's lost a fair amount of energy, I would argue, over the last 3 or 4 years. So we're rebooting the Global Framework for Climate Services to make it much more directed with the needs of funders, in particular. So actually, linking it up with things like WISER, things like CRUISE, all of those sorts of initiatives to actually do a much better job of actually listening to what the big funding organisations would like to do with Global Framework for Climate Services. And I've been doing a lot of work over the last 6 months with Max Dilley, who's the Deputy Director in charge of Climate Services at the WMO to affect that. And we're just beginning to see the first signs of some progress with that. So that, again, watch this space on that one. Very, very impossible. Very important. Not impossible. That might have been a Freudian slip. Okay, we've talked a lot about some of the other things. Sercom's got a big role in supporting some of the big top-level initiatives within the WMO. The bottom one here is really, really important. This update restructure of the WMO technical regulations, manual and guides. What Holly highlighted was the fact that we look after the global standards for weather, water, climate and related environmental services. Those standards are contained in something called the WMO technical regulations, which can only be approved by WMO Congress every 4 years. You know, they really are global standards. And they're supported by a bunch of manuals and guides and guidelines. Coming in as the president of the Services Commission, I came from an aviation background, so all my stuff was, previously, coordinating global aviation before I took on this job. It was great in aviation. We have very clear requirements, very clear standards, a whole hierarchy of guidance material. Moving into the Services Commission and having the remit for, weather, water, climate, and you name it, Standing Committee on Climate Services, it's become abundantly evident that our technical regulatory framework is not fit for purpose. And so we are going to be spending probably most of the next 5 years actually trying to sort that out and actually starting to write standards that are proper standards that actually deliver on what the user requirements are, and a whole hierarchy of guidance material that enables that capacity development that I've talked about quite extensively earlier in this talk. To deliver on that sort of 5-year vision for sorting that out in the early warning services sort of ambition as well, I will need to get re-elected again in early 2024. So I'm running through a 4-year term. It's just like United States president. You're out in your ear if you don't get re-elected. At the moment, we're pretty confident that I'll get re-elected early 2024, and that will take me through to the end of my second term, and that's me finished with WMO in 2028. So that's my target for a lot of this big, these big rocks, is actually that 2027 to 28 time frame. I was just about to say next slide, because I've been in Geneva for the last 2 weeks asking someone to control my size. So if I'd have said next slide, I've been sat here for a while. Just to give you an idea of the scope of not just what I do, but the experts that we have working in the WMO system. Holly said we've got around about 70 experts spread across the Research Board, Infrastructure Commission and the Services Commission. It's really, really busy. I would not have accepted going for this role or being put forward, more accurately, for this role by the UK. It was the UK who put me forward. Were I not actually able to convince the exec that this needed to be my job. As you'll see from the list that I'm providing here, there isn't a lot of time to do much else, although the Met Office, bless it, does try to squeeze some other bits and bobs in for me just to keep me out of mischief. But you can see over the last 6 months, particularly now as we're getting more into the hybrid sort of delivery rather than virtual only, things are really beginning to accelerate as we actually get people moving around the planet again. And there's just a whole list there of the various meetings and initiatives that I've either led or been involved in over the course of the last 6 months. And again, you can see the climate coordination group or panel, sorry, wrong acronym, bad boy in. Climate coordination panel, again, that they've had a couple of meetings this year, mostly focusing on the global framework for climate services. So really, really busy old time, and we're really picking up the pace. And one of the examples of that was last week. I was in Geneva last week and the week before, chairing the first face-to-face meeting, big face-to-face meeting that the WMO has held in over 2 years. It was the Services Commission Management Group. It was great to have 20 people in the room, utterly exhausting. Had to chair it for 30 hours last week, sat at the front, with some people obviously on hybrid mode, but it was amazing the progress we were able to make actually just doing that stuff face to face again. So I just want to give you an idea of what's coming up really, a bit of a focus on, not just where the Services Commission sits, but actually, where within the wider WMO system. At the moment, we've got an insane period of standing committee meetings. The Services Commission has 6 standing committees and 3 study groups. 3 study groups look at energy, health, and I've forgotten the third one, urban services, I beg your pardon, again, relevant to climate change. So lots and lots of activities going on there as we move back into hybrid and then eventually back into face-to-face mode. It all sounds very glamorous, but in just over a week's time, I'll be jumping on a plane to Bali. not on holiday. That is for the UN DRR Global Platform. And again, the focus on that will very much be on the Sendai development goals, the early warning 5-year challenge, and also the reboot of GFCS. So I'm going to be a busy boy for a week at the UN DRR in Bali in just over 2 weeks' time, or just under 2 weeks. We've then got Executive Council in June in Geneva, again face-to-face. Penny will be there with the international gang. I will be there with the Services Commission President. I do not sit on our delegation. I can do my own thing. It's great. Nothing like annoying your boss from time to time. But again, fantastic opportunity to see some new faces and get some real proper heavyweight strategic stuff done. And then through the October and November timeframe, we have the Services Commission Intergovernmental Session in Geneva, face-to-face. We'd have been around for 3.5 years by that point, and it'll be the first time that we've got 300 or 400 people in the room talking about everything to do with technical regulation, global framework for climate services, and actually beginning to move the agenda forward for that. In the middle weekend, because the Infrastructure Commission will be meeting the week after us, we're planning to have a joint technical session, a TECO, where we're going to be focusing on early warning systems and seasonal forecasting, and being very brave in inviting the big tech companies in, the Googles of this world, Amazon Web Services, because if WMO doesn't start engaging in a more proactive way with the big techs, they're going to go away and do it anyway. Okay, so that again is something we're quite excited about, how we do that and have an equal partnership moving forward. COP27 in Egypt, got the State of Climate Services report going into that. We've also got an assessment going through on the drive to green technologies from the WMO within that as well. We've also got something called the Climate Risk Coalition, where we've been working with the Cabinet Office, WMO, and UNDRR on actually looking at generating climate risk assessments downscaled to the regional and national levels for later on in this century, to actually drive more of the, making it more obvious about what the impacts of climate change are. And we're probably going to be using South Africa as an example of the impacts of climate change and actually enabling South Africa to do a better job of its climate change risk assessment and associated impacts for later on this year. And then beyond that, now I've corrected the dates, we've got another Executive Council early in 2023, and then the big all singing, all dancing, where we've got all the members together, WMO Congress, 19th session in June next year. That will probably be a full face-to-face event. So very exciting to get back doing some face-to-face work again. So that's it from me for now. There is a link there which is on the presentation, which I'm sure you'll all have access to our website from the Services Commission. You can probably navigate yourself away to look at various other aspects of what the WMO is about and why we're doing it. But for the time being, Alex, I will leave it there. Thank you very much.
Thank you, Ian. So that was a really nice presentation, and I can see you've just sat down again, but I'm going to ask you to get up again now because we now have a question and answer session with our two speakers from this morning. So I, of course, invite questions from the room and any questions online that we may have as well. Yes, Rosie at the back. Can we get it online?
Microphone.
Yes, we need to make sure that for those in the room, we need to make sure that the questions can be heard online. So please wait for the microphone to arrive.
I've got the microphone. This is where I'm to hold it apparently. So
go for
I have a question for Ian. That was really interesting to learn about your work at the WMO, and it was something that I was completely unaware of, and that we had that link. What's the best way for us to stay updated and connected to the work you're doing at WMO so that we can align our work? So I work in international climate services for context, and it sounds like there's a lot of things we could learn from what you're doing at WMO. So what's the best way to stay updated?
Yeah, I mean, it's Nairi and Holly's role, supported by the international team, to make sure that we actually do a more effective job of utilising internal communications like METNET and all the rest of it for actually getting that message across corporately. Nairi and I did a piece to camera in September last year, in between various disruptions from COVID, where she interviewed me, and it's about 20 minutes long. It just goes to show how crazy things are that we still haven't uploaded that onto METNet and properly advertised it. So again, it's things like this, things like doing that METNet bit, getting it more into the culture of this organisation. I mean, the Met Office and indeed the UK, everything that we do on weather, water, climate and environmental services, it doesn't work unless we're part of the WMO system. One of the battles we've had recently is with the crisis in Ukraine, is all sorts of weird and wonderful stuff on behalf of UK government, want to switch off observations and all the rest of it. And it's only then when you realise the influence that you've actually got in preventing crazy stuff happening that you realise how important and integrated into what the Met Office and actually the UK does. But I suppose it is one of the frustrations that we've never done quite a good enough job on actually getting this mainstreamed as being an integral part of everything this organisation is about. All ideas welcome, Rosie. Thank you.
Thank you for that. Have we any questions from online, perchance?
We do have a question from online.
Excellent.
The question is, how has the focus on climate and climate services changed over the years? Have you seen a greater focus in this area more recently? So how has the focus on climate and climate services changed over the years? Have you seen a greater focus in this area more recently?
Yeah, there's two aspects to the answer to that. So, if we go back over I've been involved with WMO for 20 years, all right, through various roles. Over the last 20 years, taken as a whole, inevitably an increasing sort of focus on all things climate services, seasonal forecasts, climate change risk assessments and what have you. No question about it. However, as I said during my presentation, about 10 years ago, there was this real concerted effort through the launch of the Global Framework to Climate Services to actually get it properly mainstreamed into everything that we do within the WMO. And after a bit of a fanfare for maybe 2 or 3 years, that momentum I've seen sort of dribbling away a little bit. So whilst over the last 20 years, without a shadow of a doubt, I think over the last sort of 5 years or so, we've lost a significant amount of momentum, and unfortunately, I think again I'm going to blame everything on COVID. But the last 2 or 3 years has been particularly challenging because we very much focused on the more general reform, getting the whole of the WMO, turned upside down, throw it up in the air, see where the pieces land, and put it back together. And also, the fact that in doing that and actually rebooting the Global Framework for Climate Services has been more difficult than it would have been if we could have sat in a room, dark rooms, with doors closed and what have you, to actually affect that reboot. I do see a rejuvenation now. COP26 was a big deal. The COPs are all over the place, but what we did for COP26 is the Met Office partnered with the WMO. We had a joint pavilion, and there was an awful lot of joint work actually that we did at COP26, not part of the negotiating teams, but actually around the sidelines and what have you. And that has evidenced, the benefit of the climate. So the State of Climate report is now mentioned in the COP26 declaration. We're now exploring other things that the WMO does that needs to be referenced as well. So like the SOF, the observation side of things, they want to have the importance of having this benchmarking network of observations, not just to power our NWP, but actually to properly be able to measure what's going on with climate change, in the accurate way that we need to do. There's that side of things as well. And also these climate change risk assessments. We're very used to the work that's done by the Committee on Climate Change here in the UK, climate change risk assessment that's been led on that for many, many years. We're all very familiar with UK CP09, UK CP18. That is an absolutely world-leading capability that we have here in the UK. It's absolutely right up there, front, left and centre, the best of the best. That is not the case probably for about 150 of our 193 members who really, really do struggle with downscaling this information into the regional and the national scale. And that's what we've agreed to do, sort of post COP26, is to put much more emphasis on actually that regional downscaling. And the Met Office has a big role to play here. We've got 1.2 billion quid's worth of investment in this super duper new supercomputer, working with Microsoft. And what that should be about, a significant amount of that, is obviously making that available and accessible to more members, doing the downscaling and actually informing those better climate change risk assessments. Because by doing that, there's more pressure on the politicians then to actually do more to mitigate rather than just adapt to the impacts of climate change, and all the shocking announcements today about it being 50-50. But more on that later.
Yes, we will hear more about that later. Holly, have you anything to add from your perspective?
Maybe just going back to Rosie's question earlier, I think one of the challenges that Naira and I have in our team is kind of knowing where what's going on with WMO is linking into what we are doing everywhere across the office. So like Ian said, there is some work kind of in showing what we're doing with WMO, but also kind of us knowing people getting into contact with stuff they're doing so that we can then know to send stuff on when things are coming up, like with big events like EC or Congress where papers are being decided, we can kind of run that by the people who it might impact on their work here at the Met Office. So please do get in touch.
Thank you for that. Have we any more questions from anybody in the room or online indeed? Anybody? Do we have a question from online?
We do have a question. We do have a question from online. So Bruce asks, there is a strong mode of climate services delivered from the global north to the global south, yet there are frequently strong cultural value and priority contrasts that are often missed. Do you have a view on how this could be or should evolve? So there is a strong mode of climate services delivered from the global north to the global south, yet there are frequently strong cultural value and priority contrasts that are often missed. Do you have a view on how this could or should evolve? Thank you.
Blimey, that's a nice easy question, isn't it? I do. I mean, certainly from the Services Commission, reflecting on our management group last week. And again, I'm just going to go for one sector because it could be a really, really broad question. This. We're looking within the Services Commission at the moment at the issue of gender, all right? And it's not just about gender equality of representation, it's about gender sensitive, and inclusive sort of services, because the ways in which, in many parts of the world, if we talk about the South, the needs of women and the cultural sort of requirements and what have you are indeed being missed. And so what we're actually to do, certainly for gender at the moment, is using a bit of pilot's the wrong word, but to actually look at that particular area about what the needs are and how we can respond to those needs in a more inclusive and sensitive way for the services, the standards that we write, the guidance that we write, and to actually take the 193 members that we've got with us, because with 193 members, you can imagine the different cultures that we've got, both, religion, the way in which the different societies actually operate and what have you. So, it's something that we've not done a good enough job on in the past, but is definitely within the Services Commission. I can say that because I'm the president of the Services Commission, that we're looking to explore in one specific area at the moment, but then looking to expand that once we've learned the lessons from what we're doing on the gender side of things. Thank you.
Excellent.
I'd just say as well, from a Met Office perspective, the reform gave us a really good opportunity to review the diversity of our experts that we are putting into WMO. And that's something I'll be picking up work again now I'm back in the role with the ED&I group to try and make the expert selection process from our side kind of more inclusive.
Very good. It certainly seems to be an area of keen development in the coming years.
Just one thing on that as well, Alex, because one of the reasons for the UK and actually the Met Office supporting, my being the president, is actually what it gives us is, even though I can go completely cowboy on all this and all the rest of it, it actually gives us significant influence to actually affect the changes that we think are the right things to do. And we all know that one of the things Penny's very, very passionate about are issues of equality, culture, well-being and all the rest of it. So through what I do within the Services Commission, even though I can't be explicit about this is what Penny would like to see, obviously it's part of the culture, the DNA that is, you know, somebody who works from the Met Office for many, many years, actually trying to translate that into affect those changes as well.
Yes, it's a good opportunity to get that out onto a broader footing. I think we have time for certainly one more question. Oh, we have one over there. Can Mr. Microphone get over there?
Yeah, I was just wondering where you think the global framework for climate services is implemented well and what we can learn from that, and perhaps also where it might not be working so well, or if there's any examples that you can give of where it's working well.
Yeah, again, it's a fantastic question. I'll risk Chris Hewitt was here right now because he'd be able to give some very, very specifics. I mean, unsurprisingly, we've got a small number of places in the world where it's working well. You know, we work in terms of the WMO role in implementing it. So we've got stuff going on in Brazil, we've got stuff going on in India, there's some stuff going on in South Africa. Where we're really not doing well are those much smaller island developing states and least developed countries, i.e. typically the ones that we really do need to be engaging with, you know, that really do have the greatest need. Because unfortunately, you know, the sort of infrastructure that we're dealing with, both at the government and the organisational level in those countries, makes it really, really difficult to find the right partners to actually do that as well. And that is one of the reasons why we're just trying to refocus Global Framework for Climate Services on what the big funders would really like us to focus on, because it's actually, you know, I mean, WMO is a poverty-struck UN organisation. You know, to be absolutely honest, it's not a rich organisation. Resource mobilisation and external fundings using our expertise is actually, you know, what drives most of our activities. And so actually, you know, targeting those LDCs and the small island developing states, you know, and encouraging, you know, the funders actually to, you know, to focus on some of those as well. And hopefully we can start to redress that balance a bit, because GFCS was just big overarching framework, and now we're just trying to be a bit more focused on specific needs in some of the smaller, more desperate countries. Thank you.
Yeah. Holly, have you anything to mention about the framework? Or?
No, I'm afraid that's not my area of expertise.
Fair enough. What time are we on? Have we one remaining question? I believe we have a question from online.
We do have another question from online. Do you have another question from online? So Bruce asks, how do you see the balance between easily scalable supply chain delivery and labour-intensive co-production of knowledge evolving within climate services? So how do you see the balance between easily scalable supply chain delivery and labour-intensive co-production of knowledge evolving within climate services? Thanks, Bruce, for your questions.
Yes, thank you. It's a toughie.
Well, it's not just a toughie. I mean, again, we're, you know, I'm going to do my get out of jail free card here. In that, you know, obviously Chris might be able to offer some more detail on that one. Yeah, I mean, I really, yeah, rather than just flannel it, I'm going to have to, you know, do a proper pass on that. That one's over and above my pay grade at the end of the day. So sorry, Bruce. I'm sure it's a very good question. I'm just struggling actually with coming up with a sensible answer.
I know from my experience in the EUCP project, we've worked a lot with climate information users, and we've found co-production to be a very valuable tool. It gives us as scientists a really good insight into what is actually needed versus what we can produce. And we find that the users really benefit from it as well, because they get to learn about what we're able to do, we're able to give them things that they didn't know they needed. So I think user involvement and co-production is definitely a significant area for further development. And we've found various exciting avenues for that in the EUCP project, and hopefully we'll be able to continue that on in future.
Thanks for saying that, because you've actually helped me enormously there with actually contextualising what that question was about. Yeah. I mean, it is the absolute challenge. I mean, you cannot do any service without understanding what the user wants. No. If you're not involved in the user in that production needs process, you're going to fail. And one of the things we're doing at the moment is something called the Global Data Processing and Forecasting System pilot on seasonal to sub-seasonal forecasting. All right, so this is climate service, one of the climate services, and what we're trying to understand is the way in which we pass requirements coming from the end users through the Services Commission, and then hand them across the Infrastructure Commission, who run all the clever stuff with the data, the observations, the modelling, and then identify the gaps, the research board to identify the science gaps that still need being answering. And we're just trying to understand how that value cycle actually works, and where we can each add some value within it, and everybody's responsibilities. I mean, the whole thing is, the Met Office has understood this forever, is that if you've got a bunch of wonderful scientists saying this is what you need, and then you've got the users saying no, but this is what I actually want. If you don't combine those together, you very, very quickly end up with something that's not keeping anybody happy. So yeah, it's fundamental to everything. It always has been. We're exploring ways of actually doing that in a more effective, mutually understandable way within the WMO.
Yes, of course, it'll be exciting to see how that develops in future. If there aren't any more questions, I think it might be time to draw this to a close. So last call, anybody in the room or online? Have we anything else? Doesn't look like it. So I'd like to again thank Holly and Ian for joining us today, telling us all about the WMO. So I think we'll move on to the next part of the session.
Thank you very much.
Thank you. Yep. Cheers, and don't be shy.
Yep.
Get in touch. Thanks, Alex.
Thank you. So yes, we can move on to the next part of the session now, I think. So I'm sure we're all here for the WMO Lead Centre Annual to Decadal Climate Prediction. This is, as I said earlier, this is a major output from the Met Office, well, led by the Met Office, but supported by a whole host of other organisations and groups. It was published at midnight last night. It's all over the morning's news, and now we get a chance to hear straight from one of the scientists who had a hand in creating it. So I'd like to invite Melissa up onto the stage, and we'll hear all about it.
Thank you. So I'm Melissa, and I'm going to be talking about the WMO Lead Centre for Annual to Decadal Climate Prediction. I have to mention the other people who've been working on this with me. One of them is Leon. He's here today. He's going to be helping with the Q&A. He's done a massive amount of work on this, so big thank you to him. And the others are Doug Smith, Adam Skaith, and Jeff Knight. So through this presentation, I'm going to give a bit of a background about decadal climate predictions, and then I'm going to talk about some potential climate services that they can be used in, and then I'm going to get into the WMO climate update. Okay. So what are decadal predictions? Well, decadal predictions are called decadal predictions as they are run for around 10 years, and they're designed to predict fluctuations in the climate system over the next few years, allowing us to investigate interannual variations in the climate system. So they really bridge the gap between seasonal and climate change projections, counting for both natural variations and climate change to give more skillful predictions of scale. So they kind of sit in this grey area between being an initial value problem and a boundary value problem, which means that both initialized, i.e. they're giving starting conditions from observations, but they're also constrained by different processes. So there's a few processes which act within this time frame. So you've got the seasonal to interannual processes, such as El Niño Southern Oscillation, ENSO, and sea ice. But then you've also got the longer time processes, like the Pacific decadal variability, the Atlantic multi-decadal variability. The timeframes are in the name there, and you've also got changes in global surface temperature. And then you've got these much longer processes, like processes which are happening in the deep ocean circulation. You've got forcing from greenhouse gas emissions, and also changes in land use. And decadal predictions kind of account for all of these things, which is why they are so powerful. So they have recently been developed, and by recent I mean that the first paper about them was by Smith et al. In 2007. So they are still experimental things. So the climate is a chaotic system, meaning its evolution is highly dependent on small changes, which can lead to drastic differences in the future. And to quantify these uncertainties, we create an ensemble, which is a set of many different forecasts, all which differ by small perturbations. So what we do is we get our model and we give it very slightly different initial conditions, and we allow it to run for a certain amount of time. And this allows us to estimate the future range of possibilities. So you can see from this graphic here how this works. And you can see that all the forecasts start off very close, but they slowly diverge. So this allows us to estimate the forecast uncertainty. We want this ensemble to be as large as possible and to contain as many different models as possible in order to reduce these uncertainties. Another reason why we need large ensembles is due to the signal to noise problem, which you might have heard about, but I'm just going to give a very quick explanation of it. So what we get is the forecast signal being much too weak in certain regions. So if we look at the time series of the North Atlantic Oscillation, the NAO, which is calculated as the difference in sea level pressure between the Icelandic low and the Azores high. And if we look at forecast years 2 to 9, we see the left-hand panel. So here we have the observations in black, the multi-model ensemble mean in red, and then the hindcast spread in the red shading. And you can see that the signal in the models is just way too low, and the spread of members is very high in comparison to the signal that we see here. But if we look at the right-hand panel, if we variance adjust the model, so we set the variance to be the same size as that in the observations in comparison to the signal in the model, we get the very thin red line shown here, and this is for an 169 member mean. If we then increase the ensemble size from 169 members to 676 members, which was done by time lagging in this paper, which is by Smith et al. In 2020, you get a very good prediction of the NAO. So the anomaly correlation coefficient here is 0.79, so you have a very skillful prediction. So this essentially means that the signal that we see in the models is an order of magnitude too weak in the climate model ensemble. And this means that we need roughly 100 times the number of ensemble members than normal to extract the signal. So this really highlights the need for large ensembles. You have to note that this doesn't happen everywhere in the climate models, so it's particularly affecting the North Atlantic, and it also happens over a range of timescales. So it's present in the seasonal forecast as well, but it is worse in the decadal forecasts. So moving on to the skill that we do have in the models. So you can see here plots of the uninitialized skill on the left-hand side. So this is from our hindcasts. So when the decadal forecast skill came out, lots of people said it was just a trend from the global warming signal. And you can see here that that is true. So looking at the left-hand column, we see that we have high skill pretty much everywhere. Stippling is stippled for the 95% confidence. We have some areas of low skill, like some areas of the Pacific Ocean, but generally skill is very high. For precipitation, it's a bit more mixed. So we have some areas of high skill, like over the North Atlantic and North Africa, but some areas where we do not have very high skill. And we see similar things for pressure. If we then look at these simulations but detrend them, so remove the global warming signal, we see that the skill does decrease, showing that some of the skill there was due to the global warming trend. but we still do have significant skill in many regions. So we still have good skill over some bits of Europe and Northern Africa. And if you look at the precipitation and pressure, it's a lot less affected by this detrending. So the skill decreases relatively less. And we still have very good skill over Africa, Northern Africa, which we'll get onto a bit later, looking at Sahel forecasts. So this really highlights the fact that there is significant skill in many regions after detrending. So the skill is not just from the global warming trend. And this also highlights the importance of non-greenhouse gases forcings, so things like anthropogenic aerosols, volcanoes, solar forcing, and ozone. So we're going to move now on to a bit of a history of decadal prediction at the Met Office. So this started off with Depressis, which is a decadal prediction system, which was created in 2007 and showed improved temperature forecasts. So the plot on the left, the right-hand top, is one of the first plots using Depressis. So here we've got black, observations in black. We've got Depressis in red, and the green triangles are the statistical forecast, which was being used before. And you can see that Depressis performs very well compared to the statistical forecast, and that it roughly follows the observations, even for such an early iteration. We then progressed, so Depressis became operational in 2010, with Depressis 2 being released in 2012, Depressis 3 in 2016, and Depressis 4, which is the current version we're using now, was released last year. So there have been many papers on decadal prediction, both within our group here at the Met Office and external to our group. We've had multiple on the NAO, so we've had NAO 1 year ahead, which these two plots are from, Dunstone et al. 2016. So the time series plot shows the observations of mean sea level pressure of an NAO index in black and the Depressis 3 NAO index in red for the first winter. And you can see that there's good correlation here. The correlation coefficient is 0.62, which is pretty high. And you can see that it's definitely captured the trend here. And you can also see the mean sea level pressure skill map for the first winter, showing that we have good skill in certain places, especially over precipitation. There's been more papers, such as papers on the multi-year NAO, extremes, African rainfall, European rainfall, and hurricanes, a few of which I'm going to touch on in a minute. So the first one I'm going to mention as an example of a potential climate services is the Edis 2012 paper on extremes. So the title of this was Forecasting the Number of Extreme Daily Events Out to a Decade Ahead. And this looked at predicting the number of extremes, which were classified as 10% chance events. And on the on the graphs, we have the percentage of years where observations are contained within the model's 90% confidence range. And we have on the left-hand side the temperature graphs, and going down, it shows the different lead times, starting at 1 year, and then the 2 year lead time, then years 2 to 6 lead time, years 5 to 9 lead time. Blue is about 70% of years were contained within the model's 90% confidence range, and yellow is 100%. So you can see that the temperature, it does well, but it becomes more kind of polarized as you get to longer lead times, whereas for precipitation, it performs very well, and it doesn't seem to be affected by lead time as much. So this paper really showed one of the first examples of using decadal prediction systems in predicting the number of extreme events. The next paper I'm going to talk about is the Sheen et al. Paper from 2016, which was on the skillful prediction of Sahel summer rainfall on interannual and multi-year timescales. So the plots at the bottom, the left-hand one shows the observations of the precipitation anomaly over the Sahel region, and the right-hand one shows the decadal predictions from our models of the Sahel region over years 2 to 5. And you can see that although the decadal predictions, the signal is a bit weaker, it is capturing the right signal, it has got the right signs in there, which is very encouraging. And then if we look at the time series at the top, this shows the normalized Sahel precipitation with the observations in black, which are using GPCC, which is the rainfall observations. And the red is depressed free for the years 2 to 5. And you can see that these two time series are highly correlated. The correlation coefficient is 0.73. So we do have very good skill on predicting Sahel summer rainfall, which is particularly important as this is an area which is particularly prone to droughts. You can see an image here from the Sahel droughts from the 70s to 80s, which were particularly badly hit. In fact, this spiked massive international aid from around the world. So this is really important work. The next paper I'm going to talk about is the Dunstone et al. Paper on skillful seasonal predictions of summer European rainfall. So the plot on the bottom left shows the model rainfall skill map, and it shows that we have pretty high skill for rainfall over a lot of Europe, especially over Scandinavia and northern Scotland. And then there's also a time series showing the observations in black and the model in red of the northern European rainfall that has been low filtered and 5-year smoothed. And you see that there's a very good correlation between this. This paper was particularly interesting because half the ensemble was initialized in November and so had a 7-month lead time, whereas the other half was initialized in May, so only had a 1-month lead time. But the May initialization didn't have better skill than the November one, which was particularly interesting. And it kind of showed that skill comes from slow changes in the ocean. That was a very interesting study. Moving on to some work that's been done on Atlantic hurricanes. So the top plot here shows the observations in black, and then the coloured boxes are the hindcasts for the number of hurricanes in 5 years. And I think the main feature to take away from this plot is that the hindcast really well captured the increase in Atlantic hurricanes in the mid-1980s. So towards the end of that plot, the red bit, that was very well captured in the hindcasts. And the plot on the bottom shows the observations in black as the anomaly from the 1961 to 2009 mean, so whether that year had above or below average hurricane activity. So the shading shows this anomaly, so blue means it had below average and red means it had above average. And the diamonds are the model output, with the model spread being shown by the bars. And I think really interesting about this plot is the forecasts in the green box. There was no observations available when these forecasts were published. And you can see that they did stay within the observations and they did capture the reduction in the 5-year mean Atlantic tropical storm frequency. Some more work that's been done on North Atlantic hurricanes is by Julia Lockwood. So this was some work that was done with C3S. So the Met Office was one of the 4 centres involved in the C3S sectoral applications of decadal climate predictions. So we were focusing on insurance, DWD was focusing on infrastructure, BSC was focusing on agriculture, CMCC was focusing on energy. So for this work, we partnered with Willis Research Network and Willis Research Towers to produce a year 1 to 5 year forecast of the North Atlantic hurricane activity. So this was developed in collaboration with the users, which is particularly interesting. And the index that they used to measure hurricane activity was from the relative temperature index. So you can see on the map plot, the skill of 2 boxes that we used. So the skill was very high here. You can see a prototype forecast for this piece of work in the top left, which is for the 2020 to 2024 North Atlantic hurricane activity forecast. And you can see the position of that in comparison to the climatology. So what has been, what the average of the past few years. So yeah, this is particularly interesting. This is a prototype climate service, so it's not operational, but provides the base for an operational climate service. So now moving on to the main climate service, which exists for annual to decadal prediction, and that is the WMO's lead centre for annual to decadal climate prediction. And this started as an informal exchange of decadal predictions among modelling centres from around the world in 2010 in order to produce a large multi-model ensemble of real-time decadal forecasts. And then this was formalised when the Met Office was designated as the lead centre for annual to decadal climate prediction in May 2017. So some of our responsibilities as the lead centre are to prepare forecast fields annually from the data collected, prepare verification statistics of the multi-model and individual models, make available up-to-date information on decadal prediction systems, and create a global annual to decadal climate update, which is a synthesis report, which is the report that went out this morning. So the first 4 of these bullet points are all within our website, which is the WMO Lead Centre Annual to Decadal Climate Prediction website, which is displayed there. And then the second part of this is the climate update, which is also available from our website. So these are the models which were used in the most recent forecasts. So here we have our global producing centres in bold, and these are the centres which contribute to us regularly and have a little bit more responsibility. And yeah, so we have a forecast centre, the model, and the ensemble size. And the other centres are the contributing centres, so they contribute to us when they can. But most centres contribute to real-time multi-model exchange of decadal predictions. They also provide hindcasts from start dates from every year from 1960. So hindcasts are retrospective forecasts that are run using the initial conditions from a certain year to give us what the model would have predicted had it been run then. These are really useful as they allow us to quantify how accurate the model is by comparing these hindcasts to the observations. So all the skill plots that I have shown previously will have used these hindcasts. And so from this multi-model ensemble, we have a total ensemble size of 118, which is good. So this is just a preview of our WMO Lead Centre website, which is where all of the operational multi-annual predictions are. So here you can see a map of all of the different centres that contribute to us. You can see that it really is an international collaboration. And here's a plot showing all of the showing the multi-model ensemble mean and each individual model for the 2022 surface temperature. So the title is a little misleading maybe. So these forecasts were initialized in November of 2021, so they predict for 2022, just something to remember. So going through a few of our features on our website. So for all of these plots here, I'm just showing the multi-model ensemble mean, but I can assure you the individual models are up there as well if you want to take a look. So the first thing we provide is the forecast. So here we have the 2021 predictions for the next 5 years for the surface temperature. We also have predictions for precipitation, sea level pressure, and the Atlantic meridional overturning circulation. And we also have on the website all of the forecasts which were issued from every year since 2010. So the 2010 forecast will be for 2011. We also have a number of different forecast periods. So we not only just produce an annual mean, but we produce a 5-year mean. And we've also recently started to do seasonal means for centres that send us monthly data, which has been a requirement from this year. So we provide data for the extended summer, so May to September, and also the extended winter, which is November to March. And we also do this for the next 5 extended summers and the next 5 extended winters. Alongside these forecasts, we provide verification statistics. So that's the middle column here. So this is showing the Pearson correlation score for surface temperature, and it's stippled where it is not significant at the 95%. confidence range. And we show verification for Pearson correlation and the receiver operating characteristic, the ROC score. And so this uses all the hindcasts from 1960 to 2018. And we provide these for the same forecast periods as provided for forecasts. We also issue time series of key indices. So we do this for global mean near surface temperature, the Atlantic multi-decadal variability, the Pacific decadal variability, and a relative Nino 3.4 index. This is the usual Nino 3.4 index, but with the temperature of the tropics removed, which basically means that we can look at El Nino Southern Oscillation without the global warming temperature trend, which makes it suitable to be used in a warming climate. There's also the Pearson correlation between the model and the observations shown for all of these time series, and they are also issued for 1 and 5 year averages. But we also have forecasts for these key indices as well on the website. So moving on to our climate update, which went out today. So this is issued annually by the WMO Lead Centre for Annual to Decadal Climate Prediction, which is us here at the Met Office. And last year there was international contributions from around the world. I'm not going to read all of those out, but it was around 12 centres. And these were climate predictions for the next 5 years. And this is now considered to be one of the key annual output reports of the WMO. And it had really amazing press coverage this year. So it was picked up by nearly all major news outlets with millions of subscribers in multiple languages. It was covered by the BBC, the Financial Times. I think it was the front cover of Financial Times. Greta Thunberg retweeted it. It was really cool. It made my day looking at the news this morning. So yeah, it went out today, and the headline result was there's a 48% chance of exceeding the 1.5 degree global temperature in the next 5 years. So note that this is relative to pre-industrial levels, so 1850 to 1900 average, and that it does not mean that we are going to exceed the Paris Agreement, as the Paris Agreement specifies that this threshold must be exceeded for a long-term average, whereas we're only talking about a single year here. So the plots I've shown here are the 2020 predictions for 2021 alongside the 2021 observations. These are for surface temperature, precipitation and sea level pressure, and they just kind of allow you to see how well we're doing. You can see that the temperature plot, we picked out the main features like the warming of the Northern Hemisphere and the different signals in the Pacific. The precipitation and the sea level pressures are a bit more mixed, but again, you can see that the main features are present there. Moving on to some key outputs, which is what I know you already wanted to get to. So here we've got one of our headline graphs. So we've got the observations in black, the hindcasts in green, and the uninitialized simulations in grey, where the shading represents the 95% confidence range. So you've also got the forecast in blue, and I think what's really important to note here is that the forecast spread is contained within the spread of the uninitialized simulations, which really just shows that running the forecasts with initializations is better than not initializing them. I think it's very important to note. In the brown bar chart, we've got the probability for exceeding the 1.5 degrees threshold for at least 1 year. And you can see that at the moment it's around 50% for the next year. We've also got the forecast probability of above average, which is 81%. So again, very high. On the right-hand side, we've got plots of the skill scores. So in the top panel, we have the plots of the Pearson correlation and the mean squared skill score, and for different lead times, so for lead times 1 to 5, and you can see that for all lead times the skill is very high, so this means that they're very confident in our forecasts. We've also got the contingency table below that. So from this, you can see that the hit rate, which is when we forecasted an event and it happened, and we've got a hit rate of 100%, which is very good. And we've got a false alarm rate, which is when we forecasted event, but it did not happen, of 18%. So again, we have very high skill. So a few takeaway messages from this. The annual mean global near surface temperature for each year between 2022 and 2026 is predicted to be between 1.1 degrees and 1.7 degrees higher than pre-industrial levels. So this is the average between 1850 and 1900. It's about as likely as not, so a 48% chance that at least one of the next 5 years will exceed the 1.5 degrees above pre-industrial levels, and this chance is increasing with time. As I've already stated, this doesn't mean that we're going to exceed the Paris Agreement, it just means we're temporarily going to exceed this threshold. And it is very unlikely, so only a 10% chance, that the 5-year mean will exceed this threshold. The chance of at least 1 year exceeding the current warmest year, 2016, in the next 5 years is 93%. And the chance of a 5-year mean for the next 5 years being higher than the previous 5 years, so 2017 to 2021, is also 93%. So those are our key global temperature forecasts, but we can move on to some more regional forecasts. So these are our forecasts for the next 5 extended summers, so May to September for 2022 to 2026. And here we have plots of the ensemble mean forecasts when we take all of our models and average them together. And we've also got plots of the probability of this being above average. So you can see from all of these are relative to the 1991 to 2020 baseline average. So here for the temperature, you can see that there's a high probability of temperatures being above average almost everywhere, with enhanced warming over land in the Northern Hemisphere. For the sea level pressure, we can see that it's anomalously low over the Mediterranean and high over the South Pacific, Southern South America, Central Africa and Australia. And predictions of precipitation show wet anomalies in the Sahel. So if we link it back to the Sahel skill that we talked about earlier, we're relatively good at forecasting in the Sahel, which I'm going to talk about in a second. We also have wet anomalies over Northern Europe, Alaska, Northern Siberia, and dry over the Amazon. So how confident are we in these regions? So there are anomalies in other regions, but I haven't mentioned those, seeing as we're not as confident in those. So here are the skill maps for this time period. So we have stippling here where positive correlation skill is not significant at the 5% level. So we see from the temperature, so we see the Pearson correlation temperature plots, and we also have a ROC score here as well. So 2 different skill metrics. So we can see for the temperature that skill is high for everywhere, basically. There's a few regions that we have lower skill for, like Central Africa, and a few places over the Southern Ocean, but generally we have very high skill, especially over the Arctic. So we have medium to high confidence in our forecast in these places. For the sea level pressure plots, we see that the skill is moderate over the Mediterranean and surrounding countries, over the Pacific, over Southern America and Australia. And we see that precipitation is moderate over the Sahel, meaning we have medium confidence in our forecasts of a wet Sahel for the next 5 summers. And it's moderate over Northern Europe, Alaska, Northern Siberia, and over the Amazon, meaning we have low to medium confidence in those regions. Moving on to the extended winter forecasts. So this is for November to March for the next 5 years. So we see from the temperature plots that warm anomalies are expected almost everywhere, with larger anomalies over land than over ocean. And we see from this that the Arctic anomaly is more than 3 times as large as the global mean anomaly. This is a phenomenon called Arctic amplification, and there's a lot of research going into this at the moment, and it is a very particularly interesting area. From the sea level pressure plots, we see that there is high pressure in the southern hemisphere mid-latitudes and low pressure over the Antarctic, which indicates a positive Antarctic oscillation index. And the pattern of increased precipitation in the tropics and the high latitudes and the reduced precipitation in the subtropics, this is consistent with climate warming. So looking at how much skill we have in these regions, so you see from the top panels, the temperature scale is high in most regions, apart from a few places like the North Pacific, bits of Asia, Australia and the Southern Ocean, which gives medium to high confidence in our forecasts. You can see that at high latitudes, so in the Arctic, we have very good skill here, meaning that we're fairly confident that of the Arctic amplification that we've predicted. We see that sea level pressure scale is medium over the Eastern Pacific, Southern Ocean and Antarctica, meaning our prediction of a positive Antarctic oscillation, we have medium confidence in that. And for the precipitation, the skill is moderate over the Northern Eurasia, Greenland and the Canadian Arctic, so meaning we have low to medium skill there, meaning that we're relatively confident in our predictions of the climate warming signal that's going on there. So that's kind of it for all of our forecasts. I'm just going to give a quick summary of what we've been through. So decadal predictions are forecast out to the next 10 years, and they capture both interannual fluctuations and long-term trends. And their potential use in climate services has been demonstrated in predicting extremes, hurricane forecasts, Sahel rainfall, etc. But many of these haven't actually been developed into climate services yet. The main climate service for the annual to decadal timescale is the WMO Lead Centre for Annual to Decadal Climate Prediction, which the Met Office leads. And our annual to decadal climate update is out today. You can find it from our website, you can find it from the Met Office Twitter, you can find it from the BBC, it's in loads of different places. Please go and have a look at it, it's got some really interesting results in it. And I think the headline result is that there's a 48% chance of exceeding the 1.5 degree global temperature in the next 5 years. So thank you for listening. I think we're going to move into a Q&A session now. So if I have any questions, I'll be happy to answer them.
Thanks for that, Melissa. I think that was a fantastic overview of this of today's news. And yes, you're right, we do have a Q&A session. So I'd like to invite any questions from the audience, both in person and online, of course. We have a question. I think the gentleman was first on the far side. So, yes, again, for those in the room, please speak your question into the microphone so that then it can be heard online properly.
Yeah, thank you. Yeah, a fantastic presentation. And just to say, this is, I'm sure you know this, but hugely important work. And obviously, it's why the media are picking up on it. And I think, so my question is around perhaps how the sort of media portrayal of the information, but also your thinking around how these predictions can be related to the various impacts that we, over the last few years, the community have been researching around 1.5 degrees. There was a special report in IPCC around the impacts of 1.5 versus 2 degrees. And of course, this isn't a sustained warming. This is the chance of 1 year out of the next 5, or at least 1 year out of the next 5. So the impacts won't necessarily be the same. But I was wondering to what extent the media are discussing those potential impacts, and also what the state of the kind of science really is around using these forecasts to translating that into the kind of impacts that people will feel.
I think Leon might have a better answer, seeing as Leon's been dealing with the media. Do you want to come up here?
I was going to say, yeah.
Yeah, Leon's been mainly dealing with the media output from this.
Yes, I think This is Leon Hermanson, another member of the seasonal to decadal climate team at the Met Office. So yes, have you?
I've been spent several hours yesterday doing interviews with the media and discussing things across. I mean, the main interest is about the headline number and how this relates to the Paris Accord, as we discussed. Yeah, I really tried to push the whole regional forecast as well, because I think that's an important part of what we do. And so, yeah, we had, as we know, we have results in Sahel. We also have results in around California, around the big mega drought they're having there. So I got some interest from, say, the Associated Press about the impacts there. I mean, we don't make any statements about extremes particularly, and I think it would be really interesting to take that further. I think that is a really good next step. You can kind of link what the global mean temperature is in a year with what impacts you might be able to relate. So I think there's research ongoing on that. So it's a really good way forward. Thanks for the question.
Rosie, you had your question as well.
Yeah, thanks so much for the talk, Melissa. I think you did a really good job explaining quite a lot of complicated material, so that was great. Obviously, I'm approaching this from a climate services perspective. How often does your team kind of work with people in climate services, or is there a way we can build in time to talk to you more often to understand where the skill is in the decadal? Because, you know, we're going out there having conversations, and I'm not as familiar with this work as I should be. So do you currently do that, or if not, how can we make that happen in the future?
We don't currently have a huge amount of conversations external to our team. It's something I'd definitely be interested in. I think there's a lot of information here that's not being used to its full potential, and there's only so much that me and Leon can do.
There was this Copernicus, the C3S that Melissa mentioned in her talk, which was really interesting to actually get some actual prototypes, and we worked with real-time forecasts just for 1 year to see how that worked, and that was a wider team, and there were some more conversations then more broadly in the Met Office. But yeah, it's definitely something we'd be interested in. Just send one of us an email and we can see what can be done.
Ian, we have a question from Ian.
Thank you very much. So Ian Lisk, you heard from me earlier. Bit of a mischief question, really. I mean, everything about the higher temperatures. Looking at the temperature anomalies, though, I mean, North Atlantic, there was a neutral or maybe even a negative anomaly there. Can you just expand a bit what's going on there? Because that might get latched onto as well for obvious reasons. Thank you.
I can take that. I've worked on that for a number of years. It's actually a sign of climate change as well. It is the climate change pattern we expect is warming everywhere, but actually cooling in the North Atlantic. And it's related to the Atlantic meridional overturning circulation, which transports heat from the southern hemisphere, from the tropics into the high latitudes. And it's why we here in Europe have much warmer weather than the same latitudes have in the US. If you draw a line across, you'll see we actually end up somewhere quite far north in Canada, and where the climate is much, much colder. So what's happening with climate change is that this circulation is slowing down, and we see that in the projections very clearly, and we do make predictions on the website for this overturning circulation for this very reason. And this slowdown in the heat transport means that it's actually getting colder. We did have a few very extreme, well, actually it was one extreme winter, I think it was 15-16, when there was a lot of heat taken out just by a particular weather pattern, but there is also a long-term slowdown of the MOC which is expected.
Thank you. Have we any other questions? Have we any questions from online, perchance? Have we not? No, not just yet. Oh, Adam, down at the front. Can we just get the microphone to you?
Thanks for a very nice presentation, Melissa. That was great. So these climate predictions are rather different to our more traditional climate projections. These are obviously initialized, like weather forecasts. And because there are lots of them, you showed nice examples of actual verification. So unlike climate projections, we can verify these, test whether they work, whether they're skillful, and then recalibrate. And some of those recalibrations are pretty big, right? You showed examples where the skill was quite limited, as well as in others where it was good. So what advice would you give to the people making climate projections, given what you now know about the performance of the model for making climate predictions? Where do you think the areas are that we might need to recalibrate, for example, climate projections, or think more carefully? Because obviously we can't verify something that's for 2100.
So obviously we've got the low skill in the North Atlantic Oscillation, which I think is one of the issues. Yeah, I think that probably needs to be thought about in climate projections. Do you have any suggestions, Leon?
Yeah, I'd like to suggest as well that we need to look harder in the Pacific, because you know, as someone pointed out in a Twitter comment, you shouldn't really read Twitter comments this morning, but I was on the train this morning and they were like, "There's been no warming since 2016. What are you talking about?" So what has happened is the Pacific, in particular tropical East Pacific, has been colder in this kind of recent period than the previous decades, and this area has a big impact on global temperatures, and that's why we haven't seen a record year. And I think that's why we can be confident that there is a record year coming, as we're saying in the reports today, because this state in the Pacific is not going to go on forever. But I'm not convinced that climate models do a very good job. We have good skill a year, maybe 2 years ahead for predicting this, but beyond that, skill disappears. But in the North Atlantic, we can look several years, a decade out, and get much better skill there. So we have the model doing a much better job of the Atlantic than doing the Pacific. So I think we need to ask how good the projections are in the Pacific and what the impacts are of that as well.
An interesting point. We have a question from online, apparently.
We do have a question from online, and it's a third question from Bruce. Thank you very much, Bruce, for your third question. The question is, I've not yet looked at the forecasts online, and this may be there, but do you plan to also talk about the changes in the driving atmospheric processes for different regions that lead to the forecast temperature / precipitation / sea level pressure changes? So again, the question is, do you plan to also talk about the changes in the driving atmospheric processes for different regions that lead to the forecast temperature / precipitation / sea level pressure changes?
Yeah, the report is pretty descriptive. It mainly describes what we can see. We have tried to put a little bit of physical insight into it. I think there could be more, and we are trying to engage with people and maybe to get more input and more kind of physical input to interpretation of the figures for next year. It's definitely something we can improve. And the other side of it is, as Melissa said, we're on the edge of climate forcing being important as well. It's as we go out several years into the future, and what's going on with the anthropogenic aerosols, if there's a volcanic eruption, what happens with the greenhouse gases is important as well. And so we need to understand better what the effect of these individual forcings are on our climate. And if we understood that better, then we might be able to actually make better interpretations of forecast signals and be more confident about the forecast. I think that's a really important area to be working on at the moment.
Sounds interesting. Returning to Rose's point from earlier about the climate services angle, you mentioned the C3S project you've been involved with. Have you had much feedback from that about the user co-production experience? Have there been any insights on that, of how useful they find all this, basically.
Yeah, I mean, the great thing about these Copernicus projects were they were worked very closely with the users. So each of the 5 centres around Europe had a particular user. Ours was Willis Towers Watson, which is a reinsurance company, and one of the biggest losses they have are these hurricanes. So they're very interested in hurricanes. For example, we came to them, here we are, we can predict hurricanes. They said, well, that's not really useful for us. Can you predict what our losses are going to be?
Exactly.
So we went back and Julia did some fantastic work, and we actually turned our prediction from a hurricane into a loss prediction. And they said, well, that's something we could actually make use of. I think it takes a while for big companies and established businesses like insurance to change how they do things, and there's a lot of market regulation in insurance that says what you can and cannot do. But I think we've made a good start to they are interested. They've been engaging with us for a number of years now on this topic. So this is definitely something we should continue with, and where we probably can find a good application.
Yeah, and just following up from that, if you want to find the C3S project on hurricanes, it is available from the C3S website, and Julia's got a really nice briefing document about the hurricanes in that.
Very nice. It sounds like that's probably quite an exciting area of development in the future. It's probably perhaps more industries getting on this, essentially, and sort of realise the value. Any more? Have we any more questions from the floor or from online? Ian has a further question.
Apologies, so I've done a mischievous question, and this now is a curiosity question. How much of the deficiencies in skill that you've talked about, or some of the good stuff on the skill, do you think is attributable to deficiencies in the observing network? I mean, we look at the Atlantic; it's really well, well, not say really well, but it's comparatively speaking, good observations network infrastructure. But the Pacific, perhaps not. Is there any sort of gut feeling for that? Because we've heard Holly talk about from the WMO perspective, trying to marry up the observation needs with the end user requirements. So I'm just wondering if there's much on sort of data denial studies and what have you for what we should be doing on the infrastructure side, which is not my bag, I might add. That's the other president. Thank you.
I mean, one thing to note is that because we're talking about decadal changes, we have to look at observations that have been existing for a long time. So a lot of our skill assessments are difficult to make because they started in time when mainly only the North Atlantic was observed. The start of the Argo period has been great for us to get observations from all around the ocean, top 2,000 meters. I mean, that's priceless for decadal prediction, because a lot of the memory of the climate system comes from the ocean that then later spills over into the over land and becomes important. So given our current forecasting system, hopefully that will continue, and where we'd like to see improvements is in higher latitudes. There's still a lot of uncertainty for us exactly what's going on at the sea ice edge, what's going on under the sea ice. So yeah, so my preference would be for working on these kind of gliders that go underneath the sea ice, and getting better observations out there on sea ice thickness and getting that into models.
You mentioned in the presentation, and the media coverage on this is heavily focusing on the prediction of 1.5 degrees. Perhaps there probably isn't an especially good answer to this, but do you think that focus might be slightly unwarranted? Do you think, are you perhaps concerned that they're not looking at the, I suppose, more ordinary prediction of future temperatures, for instance, and future rainfall and pressure and things, and focusing on that one part of the forecast?
My perspective is that you need to get people's attention, and the 1.5 degree threshold is what's going to get people's attention. And hopefully by making this more publicised, more people then go and read the report and maybe read like the regional impacts and will kind of do their own research a bit more on it. That's kind of my perspective, but I do agree with you that there is a lot more to the report than just the 1.5 degree headlines.
Yeah, no, I agree with that. I wish there was more interest in the regional forecasts, and as a advertiser for next year, and this goes along with what Ian was saying in his talk as well. There's a lot of focus going on with regional climate centres and getting kind of regional projections going, and we also want to do this with the decadal prediction. So we're going to be doing next year, hopefully, if we get everything ready in time, we're going to be doing regional predictions. So focused on a particular season, a particular region, a particular variable, and hopefully we'll be able to get some good results out there, which are also interesting. Because I think, I talked to an Indian researcher who was reviewing this work, and he was saying, well, what about the monsoon? And that's a big question. That all of South Asia's main thing they care about is the monsoon.
Exactly.
And there is actually, if you look on the forecast maps, a little blue blob of wetness, but we don't really have confidence that we have good skill there, so we haven't lifted that out. So one of the things we're going to do next year is look more at the monsoons and how we could actually make a monsoon forecast. And I think when we have these really high-profile regional variables available, I think there will be interest in other things than the 1.5 degrees. Well, that's my hope, at least.
And of course, South Asia is where we've seen that terrible heat wave lately that's made international news. The regional forecasts like that are, of course, extremely important, and I'm sure they can get a lot of interest. Definitely something to look forward to for next year. If there aren't any further questions, have we anything from online? I don't think so. I think that might actually be a good place to leave it for now, if we've nothing more. So I'd like to thank Melissa again for her brilliant presentation, and thank Leon for joining us for the Q&A. And I think shall we move on to close the session, I think. So, yep, thank you again. Right, so I'd like to thank everybody for attending the session. We heard all about the work of the WMO and how it's evolved recently and how it's hopefully going to evolve in future. And obviously the annual to decadal prediction has come out today, which has got the media in raptures, and we've heard all the great details of that. So again, thanks everyone for attending the session.